Okay, the recording has started. Any further question in the chat related to the current session will be answered immediately. Related to results, probably towards the end of the session, and related to past sessions, please use the Discord channel, and leads, if you can ping the link to the Discord channel. I'll ping that again and pin the message so people know where to join. All right, so thanks everyone for joining today's session. And again, this is another generative AI themed session. So we are going to build generative AI insights application only using SQL queries with BigQuery. If you had participated in this session from the beginning, you'd know that we did one similar application. We built one similar application as the first session this season, which is also there as part of our recording. The recording is available in codevipassana.dev page, and also the code lab is made available there. So please go there and check that for yourself. We will still go through this from the scratch. It's not like I'll say, okay, reference that module. It's not like that. We will go through this from the scratch. There's one slight difference, however, the data set and the use case is different. And also the way we have used prompting there and here, it's completely different. So what we are going to do in today's session is we will build a movie success rating prescription application. So prediction is something we've built. We'll also see how we built that with ML, Vertex AI's ML solution in the past with BigQuery. But today we'll do how to do a prescriptive solution, prescriptive app for it. For example, if you see a success rating, the IMDb rating for a movie as 7 out of 10 or 5 out of 10 or 4 out of 10, this particular application will give you a prescriptive message as to what factors influenced this rating of this particular movie, or what factors influence a movie to have a higher success rating. So that is prescriptive, right? So we'll get a prescriptive insights generated as part of this application. And for this, we are going to use Vertex AI's generative AI APIs. One of the APIs, which is Palm API, is what we use here. And what you also have to know is we will be using BigQuery's SQL only approach to this. We'll invoke this API from Vertex AI from within BigQuery itself, because our data will be uploaded to BigQuery, and that is where we'll operate the whole application. We'll create the whole application. That's about it. So we'll use an SQL only application in order to build a prescriptive movie success score insights application. Where is generative AI coming into picture here? Like I said, the API that we will use in order to create the prompt and get the desired result, prescriptive response from the API. That is the generative AI part of it, right? What is Vertex AI? Vertex AI is the suite of all ML, AI, and generative AI APIs, models, and applications that Google Cloud offers. It is available under one umbrella called Vertex AI. Where can you find it? All you have to do is just go to let me open it. Okay, console.cloud.google.com. And then I'll take you through the billing process as well. Sorry, credits activation process as well, but just to show you what Vertex AI looks like before we get started. So go to Vertex AI right here. So you should be able to see all ML, AI, and generative AI related models and APIs available as part of Vertex AI. There's not only that, not only an assortment of all these, it also is a machine learning platform where you can build your own pipelines, you can do parameter tuning, you can do model training, retraining, auto ML, custom ML, everything that you think about doing with ML, AI, and generative AI, you can do within Vertex AI service. Now, moving on, we have to activate the credits, right? So the link to the credits is available in the chat. If you haven't seen the pinned message, let me share the link to this again. Just give me 1 second. So for those who are joining for the first time and who have not, thank you, Kiran, who have not activated this, I'll just pin this message again. So just click that or copy that try GCP link. I'll open it in a new thing. Okay. So hit enter in the browser. Make sure you're logged into the account that you want to sign in to Google Cloud Console with, and sign in. And then once you sign in, it'll ask you to continue. And then it'll provide some your credentials that you need to validate. Click here to access your credits. Click there. It provides your credentials, just validate that and click accept and continue. In my case, I already have utilized this credits link, so it will not activate it again. It will say it has already been fully redeemed. Does it mean I have consumed all the $5? No, I still have $459 left, even after all these 5 different sessions that I've been through. But in your case, if you see this, that means you still have some credits left. So don't worry about it. Just go to console.cloud.google.com and land on Google Cloud Console. If you don't see this message, don't worry about it, which means you can activate the credits now. Just click accept and continue, and then it will land you on Google Cloud Console page. You should be able to see this console. And in the top left corner, make sure your project is listed. If it is not listed, click new project, create new project, provide a project name and leave the location and parent organization folder as it is and click create. In my case, it's already there, so I'm not clicking create. In your case, if it is not listed, click create and make sure the billing account that it is associated to has the $5 that you just activated. By default, it should be the case. If you have only one billing account and only one project, you will not have any confusion. It will automatically assign the active billing account to your active project. So you should be good. Now I'll give you a minute to catch up to this point because it's important that you are onboarded using the credits link that I provided, and it's important that you are on Google Cloud Console's landing page so you can get started. Any question here, you can just ping in the chat. Our leads are there, Code Vipassana leads, and they'll help you with the activation of credits if you have any showstopper here. Once you're done, please react with show of thumbs, so I know that you all have your credits and we are good to go. So where can you see the credits? So like I said, when you land on console.cloud.google.com, make sure your project is listed. Click the navigation menu, the hamburger menu in the topmost leftmost corner. Click that and scroll down, select billing, click that. You should see, since I have multiple billing accounts, it is asking me to manage. In your case, if you have only one billing account, you should just be able to see that billing account. I will say go to linked billing account. Now, in this linked billing account, on the left navigation pane again, scroll down to see credits item, click credits. In here, you should be able to see the remaining value. In yours, it should say $5. I'm going to choose a different project because the linked billing account does not have any money in this old project that I was on. So, all right, now let's get started. See, in my current project, I have billing remaining value of $459. All right, click the Google Cloud logo to come back to the Google Cloud Console page. We're good here. Let's move on. Perfect. Now, please go to the code lab, which I have pinned in one of the messages previously. So you should be here in this code lab. I just introduced the concept or introduced what we're going to build today. I just introduced the use case. So what we are building today is we build a movie success score or success rating prescription app with BigQuery's SQL queries. We'll use BigQuery to store the data, and we use BQML to use only SQL queries to access the Vertex AI's Generative AI API, which is a Palm API. We utilize that to pose a question or to, in another word, to prompt, to create a prompt and get response. So the prompt that we'll create is the key highlight in this application implementation, because we always talk about how important prompt engineering is. In today's session, you will see why it is that important, and in this particular use case, how we are achieving it. So we are only going to use SQL for it. All right, so you will see a bunch of SQL constructs. It might be new to you, but you can just copy paste and get it to execute. And the code snippet in the code lab explains what each and every construct in the snippet does. So you don't have to worry about it. Even if you miss what I'm saying in the session, you can always go back to the recording or go back to the code lab and see what exactly that particular code snippet does or query snippet does. All right. So the data set has already been created and it's already made available for you in the GitHub repository. So we'll get to that point in a bit. With that, let's go to the requirements. So you already have your billing account, you already have the project created. Let's activate Cloud Shell because we have one small step where we'll pull the data and push it into BigQuery. So in order to do that particular step, we are using Cloud Shell terminal as an interface to run our Cloud Shell commands. You could do it in multiple ways, but we are choosing to use Cloud Shell command. So it will be helpful for you to do other projects as well. All right, so this is my Google Cloud Console. How do I activate Cloud Shell? On the top right corner, you see Activate Cloud Shell icon. Click that button and it should open up the Cloud Shell terminal in the bottom. Hold it and drag to fill that page in. So you see it in a larger landscape. You don't have to keep it like in the bottom of your window. So hold it and drag it to the top so you see the whole view of it, holistic view of it. It'll take a few seconds to load. Show of thumbs, how many of you are able to activate this? Perfect. All right, so as you can see in my screen, you should be able to see your project ID displayed here. If not, just make sure you set your project ID by looking at the code lab. In the code lab, you should be able to see a command that shows how to set your project ID to the current project ID, active project ID that you're in. So what is my project ID? If you click this drop down, the top left corner, you should see your name and your project name and project ID. This is your project ID. Ideally, you should already by default see your project ID here, so you don't have to do much. All right, so we are pretty much ready with everything except one last thing where you have to enable BigQuery API, Vertex AI API, and BigQuery connection API. So with Google Cloud, you have to enable the APIs consciously because you are making a informed decision of what APIs you're going to do in your application or use in your application and enable it so you're aware of all the services that you're activating before you implement a project. So that's why we have to enable the necessary APIs. So if you go to the code lab, step number 2, which is requirements, point 2 under the before you begin section. Point 3, make sure all the necessary APIs are enabled. The enabled link is hyperlinked. So click that and copy the hyperlink and carry it over to the tab where you have the Google Cloud Console open and where you want to implement it, right? So open it in the same tab, paste it, remove the unnecessary things in the end. You don't need the GA coordinates. Just see BigQuery.googleapis.com, BigQueryConnection.googleapis.com, and AIPlatform.googleapis.com. All the three are available and hit enter. It should show you this tab, this screen where it says enable access to APIs, confirm project, yes, next. And then you're about to enable, it'll ask you for confirmation, click enable. In my case, it's already enabled, but if it's not in your case, it will enable right now. And the enable button will be disabled because it's already enabled, like you see in my screen. All right, so that's pretty much it about enabling APIs. Close that and come back to your Cloud Shell terminal window. You have enabled the APIs. Show of thumbs, how many of you were able to get this done? Thank you for confirmation. I see a lot of folks engaging and responding. Thanks a lot for that. All right, now we are ready with everything we need. We have Cloud Shell. So for folks who are joining for the first time who don't know what Cloud Shell is, like I said, where to find it, way to navigate and find it and activate it, you would have done that. But what exactly it is an interface to interact with all the Google Cloud services programmatically, or in other words, using Google Cloud Shell commands. So when you activate this Cloud Shell, activate Cloud Shell, it activates two things. It creates a Cloud Shell machine for you, and it creates a Cloud Shell, which it provides a machine and a compute for you, a storage and a compute. So it gives you two things. One is terminal, Cloud Shell terminal, and the other one is Cloud Shell editor. So you can toggle between the editor and terminal by clicking the open editor and open terminal button. So right now I'm just there in the terminal section. Open editor will open up the code editor, which has all the same features as you have in your code editor, like VS Code or Eclipse or other things, whichever you would see. It's very close to one of those editors, and you could do everything that you could do and a little more with uh, Cloud Shell editor. Right. So right now I'm in Cloud Shell terminal, and this is where I'll be able to enter my gcloud commands to execute what I want to do. Now we are all set with the prerequisites. Let's go to preparing data. Like I already said, the movies data set is made available for you. Now all we are going to do is, where I have enabled it for you is available in the GitHub repository in this project movie score Gen AI Insights. And this also has a README markdown file, which has everything, all the steps that you need to run this. But don't worry about it. All you need to copy, you don't have to copy anything from here. But if you click the movies underscore data CSV, you would be able to see everything, what the data looks like. But we are not going to copy anything from here because we are going to programmatically fetch that file and put it inside the folder in your Cloud Shell editor, and then start your BigQuery data set and all from that point. All right. So let's get started. In order to do this, first of all, like I said, we are going to use BigQuery to store the data, and we are going to use BigQuery ML to create this model, right? This generative AI application only using SQL queries. So how will we store BigQuery data in BigQuery? For that, go to console.cloud.google.com, or you can just, in the same window, right click on the Google Cloud logo and click open link in new tab. And as you can see, it's landing on the console. Now in the search bar, type BigQuery, right? So click BigQuery data warehouse /analytics. Since you have already enabled the API, it won't ask you to enable it. If it does, it means you haven't enabled in the previous step, but go ahead and click the enable API button and you should be good to go. Now, this is the Google Cloud console, the BigQuery console. And on the left, you can see Explorer. On the right, you can see BigQuery Studio. You can also create a data set for holding your movie CSV data from the console itself, but we are not going to do that. We are going to create the data set using BQ commands in Cloud Shell terminal. You can alternatively just click your project, the 3 dots next to your project, and do create data set. Okay, but we are just going to do it using gcloud commands. So in order to do that, so what is a data set in BigQuery? Data set is in BigQuery is like a database in any other structured database that you have seen, you would have used. So this is a database within which you will create all the objects that you need for your application. So in this case, the movies data set is going to be stored in a table that I'm going to be creating within this data set, which is also known as a database. In BigQuery, we call it as BigQuery dataset. It's a collection of tables and other objects within a particular scope of your application. So copy the first command, the bqmk -- location equal to US Central 1 movie underscore insights. So copy and run this from your gcloud terminal, Cloud Shell terminal. Okay. So I'm going to go back to the terminal. I'll run this command in order to create my data set in BigQuery. Hit enter. It'll ask you to authorize your Cloud Shell. Hit authorize Cloud Shell. Okay, in my case, the dataset already exists, so that's why you see already exists. I'll just change the name, but you don't worry about it. You can just create a new dataset called movie underscore insights. You should be good. See, successfully the dataset is created. Show of thumbs, how many of you were able to get the dataset created? All right, thank you, folks. So we have created the database, the container that will hold your table of data, right? So we don't have the data yet. We haven't created the table yet. We have just created the container, which is a data set. Now, what is the second step? Second step, as you can see in the code lab, step number 3, preparing data, is to clone the source file from the GitHub repository into the Cloud Shell machine to get your data. So copy that git clone command also from this code lab. I'll also paste that here in the chat. Git clone and the GitHub repository link. So paste that here. Git clone, paste it in the Cloud Shell terminal. Now it will take the everything that's there, the file that is there, and it will create a folder in your Cloud Shell editor, in your Cloud Shell machine. You don't have to look at the data at all in order to get this done. So just do git clone and the repository name, and I'll hit enter. That's it. It is created. If you want to see, you can also click open editor and see what the file looks like, the one that I just created. So where is it created? Movie score Gen AI Insights. I'll expand it, and as you can see, movies_data.csv is created. I click that and the data is loaded here. That's it. I'll toggle back to my terminal because I don't want to do anything in the editor after this. Now, going back to the code lab, we have cloned the data into a folder. Now what we have to do, there is a new folder created now, right? So I have to navigate into that folder. In order to change your directory and make your directory or move your working directory to the one that you just created, to the folder that just contains your movie data, you have to run this create directory command. So run this command from Cloud Shell terminal, cd movie_score_gen AI_insights, and hit enter. You're now inside the directory which you've just created with the file, the data file. All right. That's it. We have cloned the repository and we have taken the data. Now all that is left to do is create the table in BigQuery dataset which we just created, and import the data from the CSV which you have copied into your Cloud Shell machine. So both of these steps we are going to tackle with just one BigQuery command from Cloud Shell terminal, which is bq load. If you look at the code lab for this command, it says bq load, source format is CSV. We are taking a CSV. We are skipping the first row because it's the headers. And then movie insights dot movie score. Movie insights is the name of the data set which you just created, right? And then movie_score is going to be the name that it is going to provide to the table that it will create as part of this command. And then the name of the CSV is right here, which is there in the current working directory which you're inside at the moment in Cloud Shell machine. And then you have the fields and the corresponding data types that are present in the file that matter to you for this particular use case. So I'm going to load this. Just copy this command from the code lab. Alternatively, you can also copy it from here, from the meeting chat. I would recommend you to copy it from the code lab, because sometimes when you copy from meeting chat, it just changes the codes and other things. So I'm going to run this. Before I run this, I just created a new table, right? In your case, you don't worry, just copy and paste this. You should be good to go. So I'm going to paste this here and run this from a Cloud Shell terminal. As you can see, it takes about a few seconds and creates this table and loads the data. Upload complete and status is done. So that's it. Now we have created the table, data set, created the table and loaded the data. To confirm this, you can go to the BigQuery tab that is already open, expand your project, and scroll down to the data set that you just created, which is movies_insights, and then click the new table that got created, which is movie_score, and then you can do a preview to see if the data is loaded, or it is loaded, or you can just write a simple query as shown in the 5th step of your code lab. Just copy you can test it from BQ command as well, or you can just copy the query part, the SQL part, and paste it in BigQuery console. So where will I paste it? On the right side, you have the SQL editor. So click the plus button over there and paste your query. Select name, rating, genre, runtime from your dataset name dot table name and limit to 3. Why? Because I don't want to spend so much on fetching all the data. So I'm just fetching 3 records. As you can see, the data is loaded. Cool. Data load step is complete. How many of you have got to this point? Can you show reaction to it? Perfect. Thank you so much. I'll just wait for a minute. At 8:35, we'll get started with the next step in the code lab, which is doing the ML part of it before we do the actual generative AI part of it. Why? Because that way we'll also talk about what is the difference between ML and what we're going to do with generative AI. Please, which step, Karthik? Is it the load, preparing the data step? So for preparing the data, like I said, we created the data set in BigQuery. For that, you run this command highlighted on my screen, bqmk, location, and dataset name. And once you create the data set, you have to load the data. So where are you fetching the data from? In this case, you're using this method because I already made the data available in my GitHub repository. So you're cloning my repo and you're copying that to your Cloud Shell machine by just running this git clone command. And in the next step, you're navigating into the directory which contains the file that you need, the data file that we created. So it goes into movie score Gen AI Insights folder by using this command cd movie score Gen AI Insights. Now, after navigating to that, you will run the bq load command in order to load your data that is available in the CSV file in this folder into BigQuery. Where will it load in BigQuery? It will load inside the data set that we just created in the first step under movie insights, right? And what is the name of the table it will create? That is what you provide right here. Movie insights is a data set and movie score is a table name. You can create whatever name you want, but stick to what I've provided here. That way, when you copy paste, it's not breaking, right? And then in the bottom part of this BQ load command here, you see the column names and the corresponding data types, and that's about it. You run this, the data gets loaded inside a table inside the data set we created. In order to verify that, you can just run this BQ command in the terminal itself in step 5, or you can go to the BigQuery console and open the data set that you created, open the table that you created, open the SQL editor, and just run a select query on the table, the dataset or table name that you created, and see if the records are visible. That's about it. All right, move on. Can we move on to the next step? Maram, Pragya, John. Yeah, cool. Thank you. Perfect. Thanks for confirming. So moving on to the next step, we'll do it in 2 parts. So we are almost at we are approaching the point where we are going to build the Gen AI part of it. But before that, I'll tell you what the difference between the machine learning aspect of it. This we have done in the previous season as well, in one of the season, how to do this movie prediction using ML. But here, like I said, we're going to do a prescriptive application where we are going to use generative AI to get some insights. Whereas in ML, we predicted what its success score is going to be in the previous season. But I'm going to repeat that again in this particular step. In just 1 step and 2 queries, 2 SQL statements, you'll be able to create the model and predict using the model. So the difference between ML and generative AI here is the fact that with machine learning, you're providing training data. So in our case, I'll show you where the data is, right? We created the data, but I'll show you what the fields are. So there are 2 attributes, that is genre and runtime. Genre is horror, comedy, romance, or violence, or whatever it is, whatever is the theme of the genre of the movie. And runtime is what is the duration of that movie. So based on these 2 attributes, we are going to predict what the success score for the movie is going to be. So how is it doing the prediction? It will look at existing data. So we are providing training data in order for the model to understand this is going to be its prediction, right? So basically it's operating on a specific training data set which you are providing. So this is what machine learning is capable of. But if you think about generative AI, what generative AI is capable of doing is you don't have to provide a training data. You just ask a question, you're prompting it, and that is what we mention as the question. And then and the prompt is what we call as a question. And then the response that comes out of it should be what you desire to see, right? So how will you ensure that the response is up to your level of expectation? So that is where prompt engineering comes into picture. That is where asking the right question or engineering the prompt in the best possible way comes into picture. And today we'll do an SQL based prompting in step number 8. But before that, let's complete the typical ML aspect of it, like use a training data set and get the prediction done. So in order to do that, where is the data available? So if you go to BigQuery right here, as you can see, there is name, rating, genre, and runtime. So this rating is different from the success score. Success score is stored in a field called score. So I'll do this, right? So if you run this particular SQL, you can see the name of the movie, the rating of the movie, the genre, runtime, and the score. Say limit is 100. As you can see right here, the genre is crime, drama, action, and all that. And runtime is whatever, 88 minutes, 87 minutes, 93 minutes, depending on the length of the movie. As you can see, the score varies. So this is our training data set. We already have genre, runtime, and score. Now we are going to teach the machine and ask questions based on it, right? So that is where this part comes into picture. If you don't want to execute this command and the next step, it's okay. You can just watch. The main part that you're going to do is building the generative AI application, all right? So this is just a part which shows you how we'll do it in ML. So I'll open another tab. So here what I'm going to do is I'm going to create a model, an ML model, using logistic regression algorithm, because I want to do a classification problem, right? Why? Because I have 10 values and it has to be one of those scores, 1 or 2 or 3 or 4 or 5 up to 10. All right. So I'm using logistic regression, and I'm saying this is not required. It is storing it in Vertex AI and deploying this model as an endpoint in Vertex AI, which I'm going to skip in this particular step. You can leave it and run it. That's not a problem. And then I'm saying the target variable, or what we are going to calculate, predict from it, is score. And what is the training data you're providing? This is the training data part which you're providing. And the data category is train. So I'm saying for all the records that have the data category as train, fetch the genre and runtime and score, and run this logistic regression model. So basically use this data as training data and train yourself under the name of this model, which is model rating by runtime genre, and create a model. So that's all we're saying. All right. Now, once you're ready, just go ahead and run this particular model creation query or SQL statement and see what's going on. I'll paste this here in the chat as well if you want to run this. It'll take a few seconds to complete, or minutes. Now, if you want to validate what are the other data categories I've created, you can just do distinct on select distinct data cat from movie underscore score. So run this. See, I have only 2 categories, test and train. So I'm using the training data set to train it and the test data set to test, which we'll do right now. All right, so the model is successfully created. How many of you got the model created? Show of thumbs, please. All right, so now we are still not doing generative AI. We are only doing ML, okay, machine learning. So the model is created. Now go back to the code lab. Go to step number 5. We have created the model. We have to predict using the model we have created. So copy the select command, select query. Paste this here in the chat as well. Copy the select query. I'm going to open another tab. Paste the select query. Now what I'm going to do is, with the model I have created, I'm going to choose the test records from this particular database. From this particular table, which I've loaded just now using the BigQuery load command. And I'm going to predict the success score for the movies that are tagged as test data. All right, because I've already passed the training data. Now I'm going to pass the test data. All right, so that's it. In a minute, you are able to complete your ML application using logistic regression algorithm. As you can see right here, The Invisible Man, Birds of Prey, and all these movies are all under the test data, and they have been evaluated for the predicted score. As you can see right here, the predicted score is the first column. That's it. This is machine learning. You've completed the ML aspect of it. Now, imagine you are supposed to explain this, right? That's great that we have got this predicted score of 7, 6, 7 consistently, 7 for certain movies, 6 for some movies, 5 for some, and there are a few for which you have gotten like 2 or 3. I saw some zeros as well in the training data. Anyway, so if that is the case, so imagine you have an application that can analyze the attributes, particularly all the attributes that is there available in this data, and can give you an insight into what fields have influenced a particular movie to have a better better score. Imagine that you're able to build something like that. So that would be generative AI, right? Without passing any training information, you're asking the machine to understand the data and answer your question around what has influenced the movie to have a better success rating, right? So this is the question we are going to ask and see what response it is going to provide. But in order to do that, there are three things. One, the data set is already available, but it is not engineered. Your question is not engineered in a way that the data is available as a story for the model to understand and provide you a response, right? There is no context. So that you need to create. Two, you need to determine what API you're going to use for it as a generative AI API or a generative AI model that you're going to use it. And three, how are you going to interface or interact, or how are you going to make your data interact with this API that you have decided to do this generative AI insight for you? So for that, for the first one, we have to do prompt engineering, but that is the last step. We'll come back to that using the SQL query. The second thing, what API? Like I said in the beginning of the session itself, we are going to use Vertex AI's generative AI API, which is the Palm API. We're going to use that, which we have decided. Why are we using Palm API? Because it gives us insights based on the prompts that you're providing. And in this case, this is text-based prompt. And this is the absolute candidate that we have as of now. Continuously look for the latest updates in the areas of generative AI APIs. For now, we have this Palm API. There are several models under it. Just take a look at what all models are there and what all algorithms are available for it and which one you want to choose, right? So based on that, I'll choose the latest one that is available as part of the Vertex AI Palm API, and I'll use that in BigQuery. In order to make that connection, now to answer your third question, how are you going to bring that API to the data? So that is where you're going to use BigQuery connection. So with BigQuery connection, you'll be able to make your data talk to Vertex AI API in order to implement the generative AI application. So those are the last three steps left for us to do. Now the ML part is completed. We are moving on to the generative AI part. I hope you understood the clear difference between these two, because that is where most people are still stuck or are thinking about, okay, I just started learning ML or I started doing ML, but now I don't know what difference it is, like what is generative AI? I hear that they are still using models for it. Are we not using models in ML? How is it different? The main difference is with ML, you are providing the training data to train the model and to predict using it, derive insights using that model. Whereas in generative AI, the model is already trained and made available for you. You're only asking the prompt and you're providing data only in the form of a context. You're not training the model itself. But there is a possibility for you or a requirement for you to fine tune your model to provide response in a way that you want your response to be, in which case you will fine tune the model, but that is still not training the model. You're only fine tuning the responses, but not the model itself, right? So we are not looking at fine tuning today in this session. That's for another season. But for now, we are just going to build the generative AI prompt and create the connection and get this SQL done. All right, so move on to the sixth step of the implementation, which is data to generative AI. I already explained the three steps that you need to do. We will use the same table that we created, which is movie_score, which contains the data. All right. Now we will use the external connection to make BigQuery talk to the Vertex AI API. All right. So let's see how to do that. Click step 6 of your code lab. If you see that, it says to enable BQ connection API, you have to first, you should have enabled the API at the beginning of the session. I hope you all already have completed that step. If not, it will ask you to do that at this point when you click the connection button. Please enable that API. That's important to proceed with this step. So how to do this? Go to Google Cloud Console, BigQuery. You're on BigQuery Explorer, BigQuery console. In the Explorer pane of BigQuery, you would see the Add button. Click Add button. It will open a pop-up that has source and popular sources. So in popular sources, the third option, which is connections to external data sources. Click that. That's what we are going to do right now, because we are connecting BigQuery to Vertex AI. So this is an external data source. So that's what we're going to do right now. Connection type, click the drop down and select Big Lake and remote functions. Because we're going to use Vertex AI API as an exposed remote function in BigQuery. So we are choosing this particular connection type. Connection ID, go back to the code lab and copy the connection ID that is recommended there. You can choose anything you want, but just for the sake of not breaking the chain of steps and not having to change so much from your end. Just copy paste whatever is instructed in the code lab for now for the demo app. So it's BQ underscore LLM underscore connection. Provide that over here. In my case, I already have it, so I'm selecting another one. Don't worry about it. You just follow the code lab. And then region, I'm going to select it as region because we want to make sure the region that we have our data in and the region that our connection external connection is built is in the same region. Right, so I'm going to choose region as US Central 1. Click that and click create connection. That's it. Once you click create connection, you should be able to go to connection, click here and go to connection. Do that. But before that, let me pause for a second here. I forgot to ask how many of you were able to successfully complete the prediction step. Show of thumbs, please. Okay, a lot of you have completed the prediction step. That's good to see. Now, how many of you are able to get to this point of creating the connection? All right, thank you so much for confirming. All right, so now that you've created the connection, navigate to the connection that you created by clicking the Go to Connection button. Appears once you completed the creation of the connection part. I see somebody had a question or raised your hand. Feel free to type your question in the chat. Our leads will take a look at it and answer if possible. Thank you so much for that. So in the connection info screen, from the connection info configuration page, you should be able to copy just the service account ID. Please copy that to your clipboard or copy and paste it in your notepad or something. Keep it handy because we need to provide access or we need to provision permissions for this service account in order to access the Vertex AI API, right? So copy this. And now moving on to the permission step, go to the code lab, go to same steps, step number 7, bottom part, which says grant permissions. So you have copied, pasted the service account, you keep it handy. Now we're going to grant it permissions. So in order to do that, you can use the same tab or right click on the Google Cloud logo, open a new tab, all right, under the same project, right? Make sure everything is same, nothing is changed. So click the navigation menu on the top left corner and open IAM and admin. Alternatively, you can search for IAM and admin on the search bar as well and land on this page. It'll open the IAM console, which is Identity and Access Management Console. As you can see, permissions are listed. So I'm going to click Grant Access, which is what you should do. Under View by Principals tab, click that. And in the New Principals text box, paste the service account that you just copied and hit Enter. Don't worry if it doesn't drop down like it did for me. You just click Enter. It'll assign the new principal. And now you're going to assign roles. Click Assign Roles drop down and search for. In the filter, you can type Vertex AI directly. Vertex space AI space user. Select that. You understand why we are doing this, right? Because we want BigQuery data. We want BQML to access Vertex AI's API as a remote function. So we are granting this external connection, the BigQuery connection. We are granting it permission to become a Vertex AI user. That's why we're doing this. So click Vertex AI user. That's it. It's been added. And now click Save. That's about it. It's there in this. If you don't want to type, just copy it from the code lab. Vertex AI user. I've pasted it in the chat as well. So for connection part, so many repeat asks. So all you have to do is in the BigQuery console Explorer tab, in the Explorer pane, click Add button. And once you click Add, under Popular Sources, choose External Data Sources because we are connecting BigQuery externally to Vertex AI. So in connection type, choose Remote, Big Lake and Remote Functions. It is the second last one. And then provide the same connection ID that is recommended in the code lab. You can type anything you want, but make sure that it is you follow what is there in the code lab for now. And choose a location type as the same location that you chose for the data set. This is where you're creating the connection, right? So choose that as US Central 1, and then click Create Connection. That's about it. All right, so now that the connection is created, permission is provided. So how did I provide permission? Right click Google Cloud logo, open a new tab, and on the navigation menu, choose IAM and admin, or type IAM and admin on the search bar and open the IAM console. Under View by Principals tab in the Permissions tab, you should see Grant Access button. Click Grant Access, paste the service account that you created, sorry, not principal. Paste the service account that you copied, and then assign the role as Vertex AI user, which you copied from the code lab. Select that and click save. That's about it. Your connection has been created and permission has been granted. Moving on to the next step. We are almost there. Now we are going to build we are going to create or register the model in BigQuery. The model that, so we are going to create a model that invokes the API that is in Vertex AI, the generative AI API, the PaLM API from Vertex AI. This is the step that does it. So copy this create or replace model statement. So I'll explain. Create or replace model as an SQL construct. Movie underscore insights is a data set name. And LLM model is the name of the model. It can be anything, but for the sake of consistency, just do the same thing for the lab as in the lab. It's a remote method. And connection, this is the connection name, region.connection name that you just created. And remote service type. So this refers to the PaLM API from Vertex AI. So it refers to that particular API in Vertex AI. Instead of remote service type, you can also directly call the endpoint. But I've just used the remote service type method. So just copy this. Using the endpoint is way better because it lets you choose the version and choose the latest one as well. So here is the command. I'm going to run this here in BigQuery. Go back to your BigQuery console. Open, close the connection tab, open a new SQL tab, paste this, and under the data set you have just created, just run this particular query, create or replace model command, and it should be able to create the model immediately. In my case, the model is already created, right? You don't have to go to model here, just create it and go back to the code lab. You can skip step 9 and go to step 10 because it is in step 9 is where I'm talking about the prompt. Actually, stay in step 9. I'll just tell you what the difference is. Step 9 and step 10 are the same context. The only difference is I've included a flatten the query construct in page 10 in step 10. The reason is the result that you get from the query that I've implemented in the generative AI query in step 9 is nested, and step 10 is a flattened version of the query result. That's all. So stay in step 9 because I've explained the attributes as well. So as you can see, this is the select query. That's it. This is the last step. In 1 minute, you'll complete the Gen AI app. So this step actually takes the data that we are going to provide as prompt. I'll explain how it is working. And then it will call the model that we just implemented, which we just created, right, to call the generative AI API from Vertex AI. So it will create the prompt. It will talk to the Vertex AI's PaLM API, and it will generate the result for your prompt. All right. So that is what this query does. So ml.generate text is the construct. It is the function that you'll use in BigQuery in order to invoke the generative AI API. Model construct has the parameter, the attribute of the model name that you just created. And this subquery, this little subquery right here is where I'm creating my prompt. So what am I doing right here? So this is my prompt text. From the following text about movies, what do you think are the factors influencing a movie score to be greater than 5? Now, this is my prompt text question. This is my actual prompt, but where is the context? I'm saying from the following text about movies. Where is the following text? So that is the part I'm giving here, which is movie underscore data. Now, what is movie underscore data? Where is it getting formed? So that is, if you scroll down, you'll find that in the subquery further below that, where you see select. So this part, replace string ag concat. So this particular thing is concatenating the fields that you saw in the BigQuery table that we created to store the data, right? The movie name, country, budget, company, runtime, genre, star, and the success score. It takes all these attributes and forms an essay out of it. It actually forms a whole paragraph. In this case, I've limited only 50 rows. Depending on what API and what version you're using, you can actually increase the limit. For demo application, I've only taken 50 rows, but you can take more sample if you want. All right. So I have formed a story using these fields. So a movie named, name of the movie, from the country with a sensor rating of rating, and a budget of budget, produced by the company, and a runtime of a specific runtime, and genre, and all those things. Starring these stars has had a success score of so many, 7 or 8 or 5, depending on what it is. So the entire thing will go in as a paragraph of text to this particular prompt. And this is where I'm actually doing the prompt engineering, right? That's it. This is passed as input to the generative AI API. And these are the parameters. Like I've explained it several times in the past, all the parameters are explained right below the query as well. Temperature will control the randomness of the response. It will stick to the context, it will stick to the story, it will stick to the prompt question. And max output tokens is the number of the amount of words you want in response. There are other parameters as well. Take a look at the documentation for further details. Now copy this query and run it, and you should be done with the generative AI app. Now, instead of copying the query from step 9, copy the query from step 10. Why? Because this has one particular line which says true as flattened JSON in output. This means it will flatten your result. That's it. So it's better on your eyes. It's easy on your eyes, and it's easy to process the result. So copy this query. I'll paste this query here as well in the chat, although it won't be copied fully. Let me see. In the, okay, genre. All right. So I've pasted the query in the chat as well, but just go to the code lab and copy the code from the query from step number 10. Copy that, go back to BigQuery, open a new tab and paste this and run this particular query. If you want to understand, if you want to break this into pieces, break it down into, want to understand the prompt further, try running the subquery at your own time after this session. Try running the subqueries individually and see what the result is and how the prompt is forming and what string add does, what concat does, what replace does. These are all pretty common SQL constructs. Run it at your own time. All right, so now it is taking one, it's understood the prompt and it has given a response. Based on the given information, the following factors seem to be influencing a movie score to be greater than 5. Genre, all the movies with a success score greater than 5 belong to the crime genre. And all the movies with a success score of greater than 5 have a sensor rating of R. So on and so forth. There's so much information available. You can export the result and you can see the response. All right. So that's pretty much it. You can see more details about what each column in the result means in the code lab. So take a look at all those things. And finally, there's nothing much to clean up here because we've used only minimal data. But if you still want to get rid of this, you can just delete the data set from BigQuery just by going to this particular data set. Click the data set and click delete from there. Click your data set and click delete. That's it. You should be good, but don't do it right now because once you complete this, you need to share the result set. So the result set should be a screenshot of your query with this result. That's it. So this screenshot you have to submit as a result. That's about it. So how many of you were able to successfully complete this step, the model and the selection part? That's really amazing to see that. Thank you so much for confirming this. And Akshay, one of our Code Vipassana leads, has pinged the result submission form link in the chat. So please feel free to take a look at that. And one more thing, we've already announced that we have a guest session today, the guest lightning talk, and we've made Meera wait for a long time right now. So sorry about that, Meera. Thanks a lot for your
No
patience.
worries.
Yeah, I'll hand it over to you. But before that, just one question. I already, what to share a screenshot? I already said that this is a screenshot that you need to share. Your result, sorry, your SQL screenshot with the query results. Both of these together. Upload it in your drive and share the drive with access to anyone with a link. Link is shared in the chat. All right. Thank you so much. Over to you, Meera.
Well, hi everyone, and thank you for having me here today. I don't have too much to show you. I will just show you an application that is complementary to what Abby just went through and what you all went through. Let me start sharing. All right, I hope you can see my screen. Yeah, you can see it almost. Awesome. So this is a tiny web application that is kind of complementary to the machine learning model that you all created today. And it allows us to predict the score of any random movie and a set of movies that we have in a MongoDB database as well. So if I go over here, you can also actually visit the URL yourself. It's publicly available. If I go here and load a random movie, I will be able to get the score, the predicted score, by sending a request to the machine learning model that I have pre-built. And we see here that for this movie called Life, we get a predicted rating of 6 out of 10, and the actual rating is 6.8, which is close enough. You can also, let's try another one, The Last of the Mohicans. Yeah, we got again sixth, and the actual rating is 7.7. The other cool thing about this application is that you can actually use autocomplete search over here. So if you start typing in any of the title, rating, director fields, you will be able to get autocomplete results. So I think we have Avalon as well. Yeah, so if I search for Avalon and click that here, all of the other fields will be populated. And this also works for the director, writer, and I think country fields. So I can start typing here and I will see a list of directors that I have in my database. And I can use that so I don't have to fill out all of these fields. So again, you can play with this application yourself and can come up with a random movie or something that you're interested in. So, for example, you can see how this movie would perform if it had a higher budget or if it was made in another country, and see how the ML model scores it. How does that work? So, as I mentioned before, it's using a MongoDB cluster that is connected to this application. This is a simple Angular application that is deployed to Google Cloud Run. And the cluster that we have is hosted in MongoDB Atlas. MongoDB Atlas is MongoDB's cloud platform, and it allows you to deploy your MongoDB database in one of the three major cloud providers. So here I have a database cluster with all of my data deployed in Google Cloud. And here is my movies database. I hope you can see it. So I have a movies database and a movies collection. And these are all of the documents of the data that is inside this collection. As you can see, this is actually the same data that we've used for training the model. It is the same data that is in the GitHub repository that Abby showed you earlier. So you can load it in your own database clusters and deploy this application that you saw if you wanted to do that. How does the autocomplete works though? So in MongoDB Atlas, we have this service called MongoDB Atlas Search that allows it to create a search index and perform full text search, including autocomplete search. So if I go to search indexes over here, we will see that we have one index called autocomplete, and we are indexing the following fields from our documents: company, director, name, star, and writer. And this is the size of the index. These are the number of documents. So we have approximately 8,000 documents in our collection. And this is the index that I have created so I can perform full text search with autocomplete. Now, after I have this index here, I can start using it. But of course, I'm using it from a web app. So how does that work? Another thing that that MongoDB Atlas offers is something called app services. So we have data services, which allow you to deploy your database in the cloud, and we also have app services, which are basically a backend services implementation that you can use. And if I go to app services here, you'll see that I have multiple backend applications. They're essentially low code applications that you can build on top of your data. And the cool part is that we have a bunch of resources available in the free tier. You can see here that even though I have a bunch of applications that I'm using in all of my demos, I'm still very underneath the free tier limitation. So we have 1 million requests for a month that we can use, 10 gigabytes of data for transfer, 500 hours of compute. So we have a pretty generous free tier, and these are all monthly, so they reset every month. And the application that they have used for this app that is currently deployed is called GraphQL Search, because I'm using a GraphQL backend to expose the data and the search index that we just saw. So this is the backend application. You can see that there's a lot of tabs and a lot of functionalities that are available. But the thing that is interesting for us is the functions tab. So if I go to functions over here, you can see that I have two serverless functions. We have get random movie, which is the button that we have in the application for loading a random movie. And we also have search movies. Now, search movies is the actual implementation of our autocomplete search. If I expand this function, you will see that this is a JavaScript function that is actually quite simple. So first, so this is the function declaration. We have parameters, we have the field, the query, which is the text that we type in, and the project stage inside our parameters. And the first thing that we do inside the body of the function is getting our cluster from the context, then getting the movies collection from that cluster. You saw that we have a database movies and then a collection movies. So this is our collection over here. And then in order to perform this search on our database, we're going to call movies collection.aggregate. And in the aggregation pipeline, we will have a couple of stages. The first stage is the dollar search stage, where we will perform the autocomplete search. So we're going to search for this particular field that we're passing in into this function. And we're going to search for this query, the query that we typed into the field. And finally, we will use the index called autocomplete. This is the search stage. The next stage is limit. So we say we want to see just 10 documents in the results. So we're limiting the number of results to 10. And finally, project. By specifying project, we are selecting the fields that we want to return. So we don't want to return every single field in our document. We are saying we want to return these specific fields, like the title of the movie, the director, the producer, and so on. Everything that we are actually interested in displaying in our application. Finally, we convert this to an array and we return it. And this is the whole implementation of the search. This is our backend. How does that work in the actual application? So as I said, we have this Angular application, and I'm going to open the service just to show you how it works. So we have different functions for searching by different fields. We have search by movie director, search by movie writer, search movie star, and so on and so on. And we are actually sending a GraphQL query. So here is the query that we're interested in. So we're saying query, we accept the actual thing that we're searching for. So the text that we typed into the search input box. And then we want to execute the search movies function. We're going to search for the field star. And this is how we pass in the query. And we want to get back only the star field. I think we also had search movie title, search movie by title. And here you can see the difference in the returned result. We have We want to return back the name, rating, genre, director, and so on, and all of these fields so we can populate the form. And this is how simple it is to create a backend and to connect it to our web application as well. And once again, this is the application that we have. So when I search for avatar, let's say the Godfather or something else, we send a search query and then we get back all of these results. And when I click on one of the results, all of the other fields will be populated for us. And that's like the whole implementation of the app using MongoDB Atlas. And the other tiny part that I'm gonna show you today is another use case of using MongoDB with BigQuery. And you might be wondering, now we have these two databases, and what is the use case for having both of them? Don't we need just one database? And the answer is that they can actually be used as complementary technologies. So MongoDB is the leading document database, so it can be used as your operational data store. It can be used as your application database. We already saw the cloud platform that allows you to deploy your database in one of the three major cloud providers. You can even create multi-cloud deployments, and it's essentially perfect for a real-time database for your applications. On the other hand, BigQuery is great for ML and for analyzing your data, and it's great for storing vast amounts of data that you want to have analyzed. And it can be used as your data warehouse. In fact, we see a lot of our customers that use MongoDB on Google Cloud using these two services together. And the thing that they built towards is actually having an operationalized data warehouse. And the way that this works is that they have their production data, their application data in MongoDB. They move it to BigQuery when they want to analyze it, and then they build their machine learning models or their analytics on BigQuery. There are multiple ways to do that, to move data from Atlas from your MongoDB instance to BigQuery. The way that we usually recommend is using a service called Dataflow that is available in Google Cloud. And Dataflow allows you to select a MongoDB Atlas collection and then transform the documents to the relational tabular model that BigQuery uses and store them there. And you can do that using either a batch job or a continuous job. So whenever you have new documents in your collection, the continuous job is detecting that, and it's transforming the documents and storing them to BigQuery so that you can analyze them there. Again, there are many different solutions to move data around. You can also have PubSub subscription and use that with a cloud function to just move the data around. You can use Confluent Cloud. You can just build your own solution and host it yourself and detect changes and move them to BigQuery. Now, Dataflow has 4 different templates, both directions and both variants, which are batch job or a continuous CDC pipeline. So these are the 4 templates that we have developed together with the Google Cloud team and that are available when you go to Dataflow. And it's quite easy to use them. Actually, you just need to enter the credentials for your MongoDB connection, the database that you want to use, and the collection that you want to use, and then connect that to a BigQuery table. Then you can specify even your own logic that transforms the documents, or you can just use the transformation that is provided by default by the template. If you're more interested in seeing how that works, we have a bunch of blog posts on the topic. Just search for MongoDB and BigQuery, and you will see how they work together. And that's everything I wanted to show you today. Again, thanks, Abby, for having me.
Absolutely, Mira. Thank you so much. This was really great, and you really consolidated all the important points, and you showed the app in action. That's really great. So, folks, for those who are following the ML aspect and the generative AI aspect, I hope this was really it was actually nailing for you to bring the pieces together and see how to incorporate that into a web application. I also shared the link to the GitHub project that has the implementation that Mira was showing. I think she just did all those things that she mentioned in about 3 or 5 hours that day. So that's how simple it was to pull that off. So just take a look at that, and you can also build your application on top of ML or the generative AI app that we built today. Thank you so much, Mira, and as usual, it's always amazing to have her on board in seasons. She's been a part of season one, and after that, season two, whether she was there a part of it or not, I think she was there as part of season two as well. And then right after that, she's only participating in season four. Thanks for that, Mira. And we'll have more seasons next year. Going into next year, we'll have more advanced topics around vector search, and we'll do a lot of RAG-based applications. We did one this season, but more of those in the next going into next year, and we'll have her on board in one of the seasons as well. Thank you so much again, Mira. Thanks everyone for joining, and I hope your questions regarding the generative AI app and submitting the results are answered. If not, please use the Discord channel to submit your questions, and our team will share the responses, and we'll be vigilant over there and revert as soon as we can. Thanks a lot once again. I'll just pin the Discord channel link and I'll stop recording. Thanks everyone for joining, and have a good night. December 7th, we have the last virtual session for this particular season. How to delete the dataset? Just go to BigQuery, open the dataset that you created, or just select the 3 dots next to the dataset and click delete. That's it. I showed that when I showed that screen. Should be there in the recording. So go back and view that. The recording will be made available in the same site, codevipassana.dev. Right? So that's about it. December 7 will be the last virtual session for the season. Yeah. For this particular season, there are some in-person sessions. There will be one on December 16th in Bangalore, December 9th in Chandigarh, and that's about it. Apart from that, virtual sessions as per the plan is complete on December 7th, and we'll assess the results that are submitted in the next 1 week, and we'll send out the email responses. The Cloud Kochi team will be collaborating with Kiran and the Cloud Kochi team, who will send out the certificates for those who've completed 5 or more labs successfully. Ask your questions and feel free to build your own applications. We are all ears for anything new that you want to implement. And yeah, the next session is by Mark Cohen. He's a Googler, and he's also a very seasoned engineer, and he'll be talking about how to build a quiz app. And that's a really fun app. I mean, it'll also be, I think he's using Flutter, although I don't know if he changed anything in the last minute, but as far as I know, the code lab is already made available. So feel free to go in there and check out the code lab by yourself. So I think he's sticking to what we planned. So it's going to be a really intriguing one as well. Thank you so much, Mira. Thanks again. And thanks everyone for joining. Have a great night. Bye.